Without further ado, what do we mean by this? So let's talk about some of the preliminaries here. We talked about, if you remember, when we talked about the S-curve and we talked about the cumulative costs, right? When we were discussing the earned value analysis, yeah? We're going to go back to that so that you can understand what do we mean by resources and what do we mean by, let's say, leveling the resources by means of whatever limitations of the resources we actually have available there. So as an example, let's go through our typical method of CPM through the precedent diagram method. So we have some activities here, we have some predecessors, we build the network, we have some durations for each and every one of these activities, and we have some costs associated with it with respect to the duration. So in this case, I have the cost per month for each and every one of these activities. The first thing that we do, we typically go and we basically build the network and then we solve it. We have a forward pass and we have a backward pass. So the forward pass is going to give us the early start and the early finish of each and every one of these activities, if you remember, and dependent upon the relationships between them, we know what's going to happen afterwards as well. So we're going to basically see this because we have B and C here. B is obviously having a longer duration. So what's going to happen? That's going to be the activity that is going to be predicting what's going to happen to activity D. So activity D cannot start anytime earlier than the finish of the maximum of these two, which activity B is going to be taking longer. That's going to be 6, and the end duration is going to be 6 plus 3, which is going to be 9, right? And then we go backwards, and then we see basically solve this. And again, here, there's going to be a slack. Obviously, this is going to be 6 and 2, but this is also going to be 6 and 3, right? Because the latest time the activity C can actually finish is going to be basically the maximum of these two, which is going to be 6, and then 3, and then the minimum of these two would predict when activity A is going to be the last time, that is going to latest time that is going to be finishing, and then we go backwards. And then we talked about the definition, and that definition was total floats, right? We said that if we have the top and the bottom of either one, so it's either early finish and early start and late start, or early finish and late finish. If these two are the same, what does that suggest for a particular activity? Exactly. It's a critical activity, or the activity is on a critical path. So if this and this is the same, or this and this is the same, so either the left or the right, what does that mean? That means that the earliest time that it could start, which is the left side here, okay, which is top, and the earliest time that it could and the latest time that it could start is going to be the same. The same on the other side here. The latest time that this activity can finish versus the earliest time that this activity can finish. If these two, either one is going to be the same, yeah, and we only need one of them to be the same, right? Because the other one is just going to be plus the duration, okay? Once that's the case, we know that that activity is going to be on the critical path. So here, what is going to be the critical path? Is going to be activity A, obviously. What about activity B or C? B, and then activity D, right? So this is going to be the critical path that we're going to be having. And then once we do that, then now we can actually build our, let's say, Gantt chart using this. Because now for something like this, it might be easy for us to basically use our imagination and build the Gantt chart. However, when it's going to get a bit more complicated, we need to actually go and build and solve this, let's say, a puzzle of a network in order for us to know what would be the earliest time that an activity can start and an earliest time that an activity can finish. So if we actually go and plug those into a Gantt chart, we're going to be getting something like this. So activity A, and now I'm just going to look at the top part here, okay? Activity A is going to be from 0 to 2. Activity B is going to be from 2 to 6. Activity C is going to be from 2 to 5. And here you can clearly see that we can actually move activity C, right? Yeah, without anything about the duration of the total project changing. That's the whole point. A critical activity in the CPM, or the critical path method, belongs to activities that if they move somehow, or if they, let's say, increase in their duration, the total project's duration would actually increase. That's how we basically talk about it. And when we formulate it, That's by means of the total float, which was a function of the early start and the late start, or the early finish and the late finish, okay? Once we have this, then we can build a cost per, let's say, duration, or cost per month in this case, because our units of duration, we talked about it in months, so let's do it that way. Once we want to do it, we can utilize basically this information from here to see what the cost is going to be. So here, the first part is going to be 10, right? Because the cost of activity A is going to be 10. So we basically go and plug this in and actually go and build it up. So the first month is going to be 10, the second month is going to be 10, the third month, what's going to happen is going to be both B, which is going to be 20, and C being carried out all together, right? And then for the next 2 months is going to be exactly the same, and the last month is going to be 20, 30, 30, 30, which is going to be activity D. Now we've built our basically resource per duration, right? Or the cost per time at a particular, let's say, in this particular project. So we can actually put it together into either a cumulative system, or we can actually put it together inside of a month by month, right? Once we have this, we can utilize it for our earned value analysis, because our planned value is exactly what we have here, right? If you remember, that's the budgeted cost of work scheduled, right? And we're going to be utilizing this in order to see if we have some limitations in our resources, what is going to happen to them, right? Okay. So now we have basically these activities that we have. We have our little cost breakdown that we have here. And we are going to be creating this basically cost histogram, which is exactly these costs that you're going to be seeing here, just translated down. This is the cost per month. Essentially, if we want to look at it in terms of the distribution, this would be the cumulative probability distribution. This would be the probability density function. Or in this case, it's just going to be a histogram because it's not going to be continuous, right? That is going to be the cost that is incurred in every month. So the first month is going to be 10, the second month is going to be 10, the third month is going to be 35, and so on and so forth, okay? Then, so now these are the preliminaries that we are basically working on, right? With this in mind, we want to basically talk about what would happen if we need to, let's say, shift this somehow. If we have some limitations, let's say that the cost of the first, let's say, day, it cannot exceed 30. What do we do there? What are some of these strategies that we can employ? And that is basically what we're going to be talking about first, and then we're going to be talking about some other means and some other strategies of optimization as well that we have to utilize in order to see whether we can meet the project credentials or not, okay? So let's go right into it with respect to resource optimization, now that we've talked about some of these preliminaries. Okay, the first one is resource leveling. This is for a time where, let's say, the cost per a particular time is going to be limited. That means that we have some limitations in our resources that we're going to be having. Therefore, we need to play around with the activities in order to make sure that the duration does not change. However, when we play around with these activities, we can actually meet or hopefully exceed those demands or that supply with respect to the cost that we have, okay? That's the first part. Then the second one that we're going to be talking about today is going to be crashing. So what does crashing mean? Crashing means that we actually, so an example of crashing would be, for instance, let's say oil and gas or any type of, let's say, production facility. Every day that the production or the operation of this is going to be delayed, there's a cost associated with that, okay? So these projects are typically very, very time driven. That means that if we can reduce the duration, every day there's going to be something that you would make, which would translate into some savings, right? Then we would be able to say, okay, there's no limitation on how much we can spend on a daily basis or on a unit of, let's say, time, monthly, yearly basis. Therefore, we can increase, let's say, the number of crews, the number of, let's say, the capacity of equipment and various different aspects in order to meet or exceed the project deadlines or crash it. So every time we can crash certain activities, and by means of that, if we can, let's say, reduce the duration by 1 day or 1 unit, we would get some savings there. The savings could be operation or production costs, or could be just simple overhead as well, right? So all of these can actually be calculated. But in this case, our assumption is that on, let's say, a unit of duration or a unit of time that we're going to be assessing this in terms of cost, we do not have limitations, meaning that we can spend more, okay? And typically some of those oil and gas projects and these projects that are very much production driven and time driven, that is what can kind of simulate something like this. So this would be another one that we're going to be talking about. And the last one that we're going to be talking about is a line of balance. And this is also dependent upon how you're going to be representing this. Here, for instance, I start from 1, which is here is going to be the units, and these are the durations. And this is basically the flow rate, or sometimes it's called production rate as well, but depending upon how it is, if you start from 0 and basically go there, that would be the flow line method. So that's going to be the representation of it. It's going to be a similar, let's say, representation, but we're going to mostly talk about the line of balance here, and we're going to do an exercise at the end of the class so that you can understand how you can actually optimize for continuity of the work in order to, let's say, minimize as much as possible the duration. So there are some strategies that you can employ dependent upon the type of project that you have that can actually support you in meeting and exceeding some of these demands, okay? So let's go and talk about our resource leveling. What was the prerequisite of this? As, let's say, an owner, I have limitations on how much I can spend on a unit of time. That would be basically what this would represent. How would that be? So let's talk about exactly the same system. Okay, we go forward and backwards. And we build our network. And then we find the critical path. And based on that, we essentially go and find our histogram. Here, then we would be able to see, based on our limitations, where that particular limitation is going to be. So let's say, as an example, this is going to be our limitation. In the beginning, we have limited cash flow. So this one here on month 3, we would not be able to pay for this project if it goes exactly like this, okay? Now this has a very simple fix, right? What can we do to actually make sure that this limitation in our cost is actually satisfied? Yes. Exactly. You move the activity C 1 unit, now this is satisfied, right? Okay, that's exactly what we do. Now when we look at it, it looks something like this. Here, the duration has not changed at all, but we are basically meeting the demands that we had with respect to the cost based on our constraints. So as a rule of thumb, typically when we look at resource leveling, what we have to look at are these activities that have some free floats, okay? We start from those activities, we move them around in a way that this is satisfied. And then if it really, really isn't satisfied and it's a hard constraint, then we have to look at some of those other activities that are on the critical path that needs to be moved around, right? And that would increase the time and the duration of the project. However, if this meeting these resource, let's say, constraints is a hard, let's say, constraint, then that's the cost that we have to pay for it, right? However, first we start with all of those activities that have a free float. What does a free float mean? That means that if you move that activity between that activity that we have here and the next activity that we're going to be having there, there's going to be some sort of float. And if you take a look at the Gantt chart, you would find many of these types of activities. And you can utilize that to move it around in order to meet these types of constraints. Once that's the case, then we can go to, let's say, critical activities and move it around and see how it goes. Okay? So this is basically the simple way that you would be able to do it. Okay? So with that being said, this is going to